Welcome to Cambridgehub. Mensuration chapter number 3 exercise 3.6. Question number 8. Question number 8. The diagram shows a cuboid with a base measuring 24 centimeter by 28 centimeter. The point M is the midpoint of AB. A triangular-based pyramid is removed from the cuboid by cutting directly from M to the diagonal of the base. Part A. Find the height of the cuboid given that the volume of the pyramid is 1092 centimeter cube. Part B. What fraction of the cuboid has been removed? In question number 8, we have given the diagram of cuboid whose base measuring 24 centimeter by 28 centimeter and M is the midpoint of AB, and we have to find out the height of the cuboid, and we have given the volume of the pyramid, which is 1092 centimeter cube. So part A, to find the area of this triangle, we can consider it as half the area of the rectangle formed by the sides 24 centimeter by and 28 centimeter divided by 2, again because M is the midpoint of AB. First of all, area of the rectangle is equal to 672 centimeter square. So area of rectangle is 672 centimeter square and area of triangle formed by the diagonal is 672 divided by 2, which is equal to 336 centimeter square. We divide it by 2 because the diagonal divides the rectangle into two equal triangles. So that's why we divide it by 2. Then area of the rectangular base of the pyramid is 336 divided by 2, which is equal to 168 centimeters square. We have taken 168, we divide 336 by 2 because the triangle is half the triangle formed by the diagonal. So that's why we divide it by 2. So the area of the triangular base is 168 centimeters square. Now we find out the height of the pyramid. The formula for finding the height of the pyramid is 1 over 3 into base area of the triangular pyramid multiplied by height. So 1 over 3 into area of the triangular pyramid, we have find out the area, triangular base area, which is 168. So we put this value, uh, 1 over 3 into 168 multiplied by h is equal to, we have given volume which is 1092. In part E, we have given the volume. The volume of the pyramid is 1092. So we put this value. So h is equal to 1092 multiplied by 3 divided by 168, which is equal to 19.5 centimeter. In part A, we have to find out the height of the cuboid. So the height of the cuboid is 19.5 centimeter. This is the answer for part A. Now part B. Part B, what fraction of the cuboid has been removed? So we have to find out the fraction of the cuboid that has been removed. So now calculate the volume. First of all, we calculate the volume of the cuboid. So volume of the cuboid is 24 multiplied by 28 multiplied by h, because we have given a length and breadth which is 24 and 28. So 24 multiplied by 28 multiplied by h, and we have find out height which is 19.5 centimeter, because in part A we have to find the height of the cuboid. So the height of the cuboid is 19.5. So we have to put this value over here, 19.5. 24 multiplied by 28 multiplied by 19.5, which is equal to 13104 centimeter cube, 13,104 centimeter cube. So now we find out the fraction removed. We have given the volume of the pyramid, which is 1092, and we have find out the volume of the cuboid, which is 13,104. So the fraction removed is 1 over 12. This is the answer. 1 over 12th fraction is removed from the cuboid. Now question number 10. Question number 10. A spherical metal ball bearing is placed into an inverted right cone of radius 4 centimeter and height 20 centimeter. The cone is filled to the top with water. The ball bearing is then removed. The water level in the cone drops by 5 millimeter. Part A. Find the radius of the top of the cone of water after the ball bearing is removed. Part B. Calculate the diameter of the ball bearing. So in part A we have to find the radius of the top of the cone of water after ball bearing is removed, and we have given a spherical metal ball bearing is placed into an inverted right cone of radius 4 centimeter. So we have given radius which is 4 centimeter, and we have given height which is 20 centimeter, and the water level in the cone drops by 5 millimeter. We change millimeter into, first of all we change millimeter into centimeter. So then we will find out the radius of the top of the cone of water after ball bearing is removed. So the water level in the cone drops by 5 millimeter. Actually 1 centimeter is equal to 10 millimeter. So 5 millimeter means we divided by 10, 5 divided by 10, which is equal to 0.5 centimeter. So we have given the height of the cone is 20 centimeter, but After ball bearing is removed, the water level drops by zero point 0.5 centimeter. So we remove zero point 0.5 centimeter, that is 20 minus 0.5, which is equal to 19.5 centimeter. Now we will find out radius. R over R, this is the formula for finding the radius. If we have given two heights and one radius, and we have to find out one radius, then we will apply this formula. R over R is equal to H over H. So we have to find out capital R divided by small r. We have given small r, which is 4 centimeter, and H over H means we capital R means whenever ball bearing is removed. After ball bearing is removed, so we are taking it as a capital R, and whenever ball bearing is removed, we are taking a height as capital H. So capital H after ball bearing is removed, and after ball bearing is removed, that is capital R. So capital H is 19.5 divided by 20. So capital R is equal to 19.5 multiplied by 4 divided by 20, which is equal to 3.9 centimeters. So radius is 3.9 centimeter after ball bearing is removed. Now part B. In part B, calculate the diameter of the ball bearing. In part B, we have to find the diameter of the ball bearing. Diameter of the ball bearing V is equal to 4 over 3 pi r cube. This is the formula for volume of the sphere. For finding the volume of the sphere, V is equal to 4 over 3 pi r cube. But we have to find out the volume of the ball bearing. So first we find out the volume of the cone before ball bearing is removed. So the formula for finding the volume of the cone is 1 over 3 pi r square h. Actually, this is the formula for finding the volume of the cone. The formula for finding the volume of the cone is 1 over 3 pi r square h. So 1 over 3 pi r square h, r is equal to 4 and h is equal to 20. So 1 over 3 pi into 4 square into 20, which is equal to 335.10 centimeter cube. This is the volume of the cone before ball bearing is removed. Now we find out the volume of the cone after ball bearing is removed. So we apply the same formula. V is equal to 1 over 3 pi r square h. After ball bearing is removed, radius is 3.9 and height is 19.5. But before ball bearing is removed, radius is 4 and height is 20. But after ball bearing is removed, radius is 3.9 and height is 19.5. So 1 over 3 into pi into 3.9 square into 19.5, which is equal to 310.59 centimeter cube. Now finally we find out the volume of the ball bearing. So volume of the ball bearing, how can we find out the volume of the ball bearing? We can find out the volume of the ball bearing with the help of the volume of the cone before ball bearing is removed and after ball bearing is removed. So the volume of the cone before ball bearing is removed is 335.10, and volume of the cone after ball bearing is removed is 310.59. So 335.10 minus 310.59, which is equal to 24.50 centimeter cube. This is the volume of the ball bearing. Now we find out the diameter of the ball bearing. Uh, we use this formula: V is equal to 4 over 3 pi r cube. So V is equal to 4 over 3 pi r cube. Volume, we have given volume which is 24.50 and is equal to 4 over 3 pi r cube. So 24.50 multiplied by 3 divided by 4 pi, which is equal to 5.8. So R is equal to 1.8 and diameter is equal to 2 times the radius. So D is equal to 2 multiplied by 1.8, which is equal to 3.6 centimeters. The diameter of the ball bearing is 3.6 centimeters. This is the answer. Now question number 12. A cylindrical container of radius 4 cm contains water to a depth of 10 cm. Three spherical marbles, each of diameter 2 cm, are dropped into the container. Calculate the rise in the level of the water. In question number 12, we have given radius of the cylindrical container, which is 4 cm, and it contains water to a depth of 10 cm, and three spherical marbles. Each marble has a diameter of 2 centimeters dropped into a container, and we have to calculate the rise in the level of the water. So first of all, we find the volume of the spherical marbles. So volume of the sphere, the formula for finding the volume of the sphere is 4 over 3 pi r cube. So diameter is 2 centimeter, and that means radius is equal to d over 2. So d is equal to 2 over 2, which is equal to 1. So radius is equal to 1. So volume is equal to 4 over 3 pi r cube means 1 cube. So 4 over 3 pi. Now we find out the volume of the three marbles. So we multiply this volume by 3 so that we can easily find out the volume of the three spherical marbles. So 3 multiplied by 4 pi over 3, which is equal to 4 pi. 4 pi is equal to 12.56 centimeter cube. Now the volume of the three spherical marbles is 12.56 centimeter cube. Now we calculate the rise in water level. So volume is equal to area of cross section multiplied by length, because we have given a cylindrical container. So the volume for finding the volume of the cylinder, the formula for finding the volume of the cylinder is area of cross section multiplied by length. So area of cross section is equal to pi r square into L, and we have find out the volume of the three marbles, which is 12.56. So 12.56 is equal to 4 in 12.56 is equal to pi into 4 square, because we have given the radius, which is 4 centimeter. So the radius of the cylindrical container is 4 centimeter. So we put this value 4 square. So L is equal to 12.56 divided by 16 pi, which is equal to 0.25 centimeter. So the rise in the level of the water is 0.25 centimeter. The rise in the water level is 0.25 centimeter. This is the answer. Question number 12 is completed. Like and share my video and subscribe my channel.